Welcome to another lecture of Psychology 101. This is your instructor, Dr. Shadi Bashai, and in today's lecture we will discuss human development, which corresponds to chapter 10 of your textbook. Human development is about change over time, and the more we understand about human development, the more we understand that both nature and nurture play a very important role in determining people's life trajectories. Perhaps there's not a case that's more illustrative of this dynamic interplay between nature and nurture than the case of the Genane quadruplets, who were four identical sisters, and identical sisters meaning they all share identical genes. All four sisters eventually went on to develop a diagnosis of schizophrenia, which is a relatively rare psychological condition affecting only 1% of the population. So the fact that all four sisters developed schizophrenia at some point in their life gives us an indication as to how much genes influence the trajectory of human life. But what's even more interesting about the case of the Genane quadruplets is that even though they all developed schizophrenia, all of them had differing severities of schizophrenia, so much so that on the less severe end of the spectrum, one sister, even with a diagnosis of schizophrenia, lived a very functional and very typical almost life trajectory. And on the other extreme end of severity in schizophrenia, there was another sister, one of the four sisters, that experienced extremely debilitating symptoms related to schizophrenia, so much so that she was hospitalized for most of her life and needed assistance in many respects. So what this illustrates is that, yes, genes are important, but they also are influenced and have a bidirectional relationship with the nature or the environment in which these genes develop or blossom over time. Okay, so it's both nature and nurture that influences human development. And what is developmental psychology? Developmental psychology is the lifelong study of processes related to change, and oftentimes these are age-related processes of change. And there are many different aspects that are studied within the field of developmental psychology, including biological aspects, maturational aspects, and social changes over time. And one thing to remember about developmental psychology is that it's not just the study of positive change or gains over time. It actually is also associated with studying or understanding losses over time and decrements in functioning and performance, especially near the end of life and the end of life trajectory, if you will. Before we dive any further into concepts related to the lecture today on human development, there are a couple of special considerations that are worthy of our attention before we talk about developmental psychology. The first of which is this concept called post hoc fallacy. And if you've listened to the first few lectures, you'll probably understand now that people are riddled with these fallacies and these problems or errors in thinking. Post hoc fallacy is yet another logical error or an error in the way we process information. And the post hoc fallacy is defined basically as when you believe that if B came after A, then A must have caused B. Okay? And of course, we understand now that just because B came after A doesn't necessarily mean that A caused B. And I'll give you, to make it very concrete, I'll give you an example to show you the absurdity of the post hoc fallacy when we really think about it in these terms. The post hoc fallacy is to assume that just because all serial killers drank milk as babies, that milk must be a cause for serial killing. And of course, that's not necessarily the case. It can't be the case, as that's a very complex behavior that is associated with a number of things. And just because drinking milk happened to precede what eventually will become somebody who does these things doesn't necessarily mean that it caused it. And then there's another consideration, which is this understanding of the bidirectionality of influence, meaning that human development really is a two-way street in the sense that a child's genes, their development, influences the environment in which they're in, but obviously also the environment influences the child back. Okay? So there is constantly a kind of a dynamic interplay between human beings as they develop and their environment, so that the environment is changing or shaping the trajectory of humanity, but the other way around as well, is that we also shape the environments in which we find ourselves in. So these special considerations should make us cognizant of the presence of several research designs that exist in the field of developmental psychology that have been designed or created to answer specific questions, again, related to human development over time. And these two research methodologies, or these two research designs that I'm alluding to, are a cross-sectional design and a longitudinal design. And in a cross-sectional design, what happens is you compare two or more groups of people who differ in age on a particular variable of interest. And I'll make this real for you, and I'll give you an example. Let's say I'm interested in understanding moral development of children over time, teenage kids over time. And in trying to understand moral development of teens over time, what I do is I get a group of 13-year-old kids, and I get a group of 15-year-old kids, and then I get a group of 17-year-old kids, all recruited at the same time and all answering questions related to moral development. Okay? So when I get a cross-section of these people on this particular trait, that is called a cross-sectional design. A longitudinal design, on the other hand, is looking at the same group of people over extended periods of time, depending on how long you require the study to go on for. Okay, so a longitudinal design, and I'll wrap it again in that exact same example that I gave earlier. Let's say I'm interested in examining moral development of teens over time. So instead of getting a group of 13-year-olds and a group of 15-year-olds and a group of 17-year-olds, which is what a cross-sectional design would look like, what I would do is I would follow the group of 13-year-old kids around for several years. And if I want to get kind of a similar effect here, I would follow that same group around for 4 years until they're 17 and see how their moral development changes across time. Okay, so these are two different research designs, and like everything else, there are pros and cons, advantages and disadvantages to either of them. One of the biggest advantages of a cross-sectional design is that it's a very cheap and easy way to conduct developmental psychology-related research. Okay, so again, you're getting a cross-section, a one-time view of a variable of interest. Okay, part of the problem, of course, is that sometimes, even though people differ in age, and one can assume that, okay, let's say in the original example that I gave with 3 kids, or the 3 groups of kids, 13, 15, and 17, and let's assume for 1 second that I find differences between the groups on their moral development. One can conclude, of course, that it's changes in moral development is mostly due to their age, which is really what my independent variable in this example would be. But given the cross-sectional nature of the design, there could be a number of other variables that we did not control for that actually accounted for the differences that we observe in the dependent variable. In this case, it would be moral development. Okay? And some of these include something called cohort effect. And cohort effect is when the historical context that one group of people grew up in or were nurtured in differs systematically from the historical context and the political context of another group of people. Okay, so even though I have a group of 13-year-olds and 15-year-olds, let's say, for example, that the group of 15-year-olds experience, as they were older, something like a tragic event that we all hear about in the news, for example. Well, that could have systematically changed the way they think about moral arguments and the way they reason morally. Okay, so that's a huge disadvantage to a cross-sectional design. Something like I was saying earlier, this concept of cohort effect, this concept that even though they're differing on age, there could be another reason as to why we're observing differences in the dependent variable. So this is less of a problem with longitudinal design. So longitudinal design does away with cohort effects, but part of the problem with longitudinal design is that it's extremely expensive to pull off research like that. So you're following people around for a large segment of time. That's extremely resource heavy. And another issue is that lots of people often drop out of longitudinal research, even though they were interested in the research at the outset of the research study. Things don't necessarily stay the same. People drop out, people move, people lose interest, whatever it may be. So both of these research designs have their pros and have their cons. I'm going to challenge you to pause the video right now and watch the two embedded YouTube clips that I have up here. And really, they're discussing two central issues in the field of the developmental psychology. One is about brain stagnation versus neuroplasticity, and neuroplasticity is a relatively new concept that research is really shining a light on. And then there's this old debate, and we've talked about this a number of times at this point, but there's another YouTube clip that talks about the old debate of nature versus nurture. And really, the second video will show you that there's really no debate at all. The more we understand about human psychology, and in fact medicine and human physiology, the more we understand that both nature and nurture work together in a very dynamic way to produce, or at least influence, human behavior and human psychology. So again, we come back to this theme of nature versus nurture. And there are three concepts that we should keep in mind when discussing this idea of nature versus nurture. The first concept is called gene-environment interaction. And this is the concept which is defined as genes will, or the level of gene expression really depends on which environment you find yourself in. That is, some people may have genes for expressed traits. Given the right conditions, these genes could manifest or become expressed in such an extreme way if they find themselves in an environment that supports that particular gene. Okay, so that's called a gene-environment interaction. And sometimes it's not a nature versus nurture. Sometimes nature works via nurture. That is, sometimes people with a specific genetic blueprint will pick out certain environments that actually makes it more likely for that gene to be expressed later on. So this is what the concept we call nature via nurture. This is when, like I was saying earlier, a genetic predisposition makes you more likely to seek out a certain environment that makes that gene express even further from other environments. Okay, so it's a very dynamic, very complex picture. And the third concept here is called gene expression. And it's a concept that comes from a field called epigenetics. And the concept of gene expression says that the activation or the activation of genes really depends on the environmental context. And we have, I'll give you some examples of that. We have lots of research coming out of epigenetics, which shows us that even though rats that have been bred to be extremely anxious, you take these rats and you put them with a surrogate mother who is not at all anxious and in fact quite nurturing, the anxiety genes that were bred into the offspring actually become turned off as a function of the presence of this nurturing, comforting, non-anxious mother. Okay? So environment really plays a very important role in determining how genes interact. So really the debate is no more this concept of nature versus nurture. It's a very complex, very dynamic system, and both are dynamically influencing one another. There are other concepts. And some of these concepts include events or certain milestones that happen before birth or right after birth. So if a developmental event of interest that we're examining or we want to find out a little bit more about happens just before birth, these are referred to as perinatal. However, when events occur right after birth, usually within a month of birth, we call these events neonatal events. Another concept, again, that should be pretty much review from your basic biology and basic sex education that you had in your high schools and elementary schools, is this idea of conception. And a conception really is defined as an ovum and a sperm meet to form what is called a zygote, which is a fertilized egg. I'll give you a graph of what that might look like. Okay, so here's the first image here is a fertilized egg, otherwise known as zygote, and it gives you the pathway of the zygote over the course of its life in the human body. And one thing to note is the fast development associated with with human development in the really early stages of life. Okay, so we go from a zygote to a 4-celled organism, if you will, in just 2 days. And in about 6 days, something gets created called a blastocyst. And a blastocyst is these specialized cells that later become whatever it is that the gene has programmed for these cells to become. Okay, so they become specialized cells in just as early as 6 days after conception. So, some important concepts and definitions related to prenatal development. A zygote is like I was saying earlier, is a fertilized egg, and as the zygotic period is 1 week. Okay, after 1 week has elapsed, we're now into the embryonic period, and the embryonic period lasts anywhere from week 2 to about week 8, and that corresponds to about the 49th day after conception, if you will. And then in the 9th week, we move into a third stage of development, prenatal development, and that is called the fetal stage. So that a fetus is any human organism, if you will, that is at the week 9 of prenatal development all the way to birth, about 38 weeks old. So remember, as I was saying earlier, one thing to note about human development is how rapid things change in the early parts of life. There is just an incredible amount of change that is occurring. And we saw this in the trajectory of the zygote as a fertilized egg, as it moves its way through the human body. And also at the level of the brain. There is just a massive explosion of growth of new neurons. And this happens at an incredible rate in the first few months of life. So anywhere from day 18 after conception and about 6 months, the neurons are growing at a rate of about 250,000 new neurons per minute. Okay. So sometimes development doesn't go as planned. Sometimes there are major obstacles or major disruptions to early parts of development. Sometimes they can happen from sources of the gene, for example. So these genetic disruptions oftentimes appear due to random errors or random problems in copying and gene copying, etc. Sometimes they occur for other reasons. For example, premature birth. And this is defined as any child that's being born prior to 36 weeks of gestation. And that can really result in a number of issues. And it's a linear relationship. That is, the less time spent in utero, the greater the chances of serious complications later on. Okay. And some of these complications relate, or obstacles to early development, relate to exposure of the growing fetus to what is called teratogens. And these are highly detrimental, highly toxic factors that arrest or make prenatal development very difficult or very problematic. And oftentimes, or at least this is what the research is showing, the introduction of teratogens creates large numbers or a large number of risks on the growing baby. So if a growing fetus gets exposed in the first, or a growing embryo in this particular case gets exposed to teratogens in the first couple of weeks of life, could mean the loss of that embryo. If the exposure happens anywhere from week 2 to week 8, during what is called the embryonic period. And the embryonic period is really associated with growth of important organs in the body. So any exposure to teratogens around that time could actually mean severe anomalies in the organ system. And then you could also have exposure later on in the fetal period. And less problems occur if there is exposure to teratogens in that fetal period. However, it is still associated with a number of risks that is now being introduced to development. One of which, and one important teratogen that I didn't name specifically, or at least two that I can think of. One is, of course, cigarette smoke or any kind of nicotine inhaled in the body. And the second is alcohol. And consumption of alcohol during pregnancy is associated with a set of disorders called fetal alcohol spectrum disorder, or FASD. And fetal alcohol spectrum disorders is a range of different disorders associated with a number of physiological but also cognitive and neuronal anomalies that happen later on in life. Okay? So the diagnosis of FASD, so like I said, it's a big umbrella term, and within it includes things like fetal alcohol syndrome, partial fetal alcohol syndrome, alcohol-related neurodevelopmental disorders, and alcohol-related birth defects. And these are, you can think of these as kind of different levels of severity of the fetal alcohol spectrum disorders. And the fetal alcohol spectrum disorders, children who suffer from that, have a pretty distinct physical features, and sometimes they amalgamate in the face. And there are a number of different features that I have in the picture present in front of you here on the right-hand side. And these are typified by a fetal alcohol spectrum disorders diagnosis. But unfortunately, the effects don't stop at the level of physiology. Fetal alcohol spectrum disorders actually are associated with a number of difficulties in cognition and a number of social difficulties, including difficulties in learning and in controlling behavior. So, for example, kids, again, this all depends on the level of severity and what kind of condition the person is actually diagnosed with. But somebody who is suffering from fetal alcohol spectrum disorders may have a hard time learning new tasks or remembering the tasks when they're asked to recall what they've learned. They may have a hard time doing basic arithmetic in their head, or reasoning generally, or issues related to understanding the consequences of one's actions. And there are social anomalies or deficits that are associated with fetal alcohol spectrum disorders as well, including problems related to getting along with other people, issues related to processing of empathy. So I guess the picture that I'm trying to paint for you here is how rapid growth takes hold. So newborn babies are born on average about 7.5 pounds. And within about 12 months, they're tripling that weight. And at 18 months, so again, think of how rapid this all is in the span of human development. And at about 18 months, most children can actually walk, and a lot of them can actually begin to talk. And again, these are milestones and averages. They're not necessarily set dates as to when these milestones will be reached. And then infancy is set to end right around the 18th months of development. And end of infancy really corresponds with the beginnings of language, and it signifies the use of abstract and symbolic language to represent the world in which the child lives. One thing to note about human development is a few trends that we see in physiological growth. And one of the very important trends is something called a cephalocaudal trend, which is translated from the Greek to mean head to tail, if you will. And a cephalocaudal trend is really typified by the growth in the head first, and then the rest of the body follows that growth in the head. And I gave you an example at the bottom here of what that might look like in terms of a cephalocaudal trend. There's also a proximate distal trend, which is what is called near to far. And this is related to growth that begins in the center of the body and then proceeds to the extremities. So these two trends, the cephalocaudal trend and proximate distal trend, are both trends that are that typify early human development. As mentioned earlier, at around about 1 year, about 18 months, lots of children begin to actually explore their environment through walking, through climbing, through manipulation of objects, etc. And I alluded to this earlier, but I think it's important for me to reiterate. There is significant variability in terms of when these milestones are actually reached. So that there's not a set date as to when people experience or go through these milestones. There appears to be a number of factors that may determine when someone may hit that particular milestones. And it doesn't necessarily need to be related to age. So here is a a pictorial depiction of all the developmental milestones related to motor skills in the first 2 years of life. And you will see here that by the time an infant is about 9 months of age, typically speaking, they're able to walk, holding on to objects. And close to about 12 months of age, they're able to walk independently without even holding anything at all. And again, typically by the time they're 17 and 20 months, they're able to do things such as walk up steps and then finally be able to kick a ball forward. And all of these things require an associated change in the brain, especially in centers of the brain around balance and the ability to maintain one's balance and coordination, etc. So around the time of birth, physicians actually begin to examine whether a baby, whether a child, is showing appropriate neurological responses. Again, this happens right at birth. Okay? And physicians are able to do this to assess the health of the neurological responding of a newborn baby through the assessment of what is called the primary reflexes. And I'm sure you've heard about or at least seen children respond in this primary reflex kind of way in the past. So if the child is showing a typical trajectory of development, they will be showing appropriate responses to the right stimuli, again related to the activity of these primary reflexes. And I'll go through these primary reflexes in a little bit more detail now. The first primary reflex that newborn babies often possess is called the Babinski reflex. And this is simply the fanning of the toes when the foot is stroked in a vertical direction. And I'm sure some of you have witnessed a child engage in the Babinski reflex once their toes, or at least their foot, is stroked. There's the Moro reflex, which involves outstretching the arms and the legs and crying. And this is usually in response to some kind of a loud stimulus or a loud noise in the child's environment. There is, of course, the rooting reflex, which is a head movement that is typically instigated by a light touch to the child's cheek. There's the sucking reflex, which is produced in response, or at least to as a reaction to a nipple or a finger being in the baby's mouth. And again, you can probably understand the evolutionary purpose or the evolutionary function of all of these primary reflexes. Okay, so this particular one, the sucking reflex, is of course associated with nutrition and consuming nutrition. If a child is lacking this primary reflex, then they're going to have a very hard time actually consuming the amount of calories and energy that they need. And then there's the grasping reflex, again, important for evolutionary reasons, but the grasping reflex is associated with basically pressing an object or a finger or whatever it may be into the palm. The child will most likely grasp onto the object or the finger there. And again, this is a newborn, natural, innate reflex that all children possess. And again, it becomes an important area of assessment very early in life to make sure that the child is showing these very important life milestones. There are other milestones, and these other milestones relate to perception. So for the most part, we've been talking about motor development, we've been talking about other physiological, prenatal periods of development or prenatal milestones of development. We have yet to focus on human perception and how that develops over time. Fance is a researcher that lived in the 1940s, 50s, and 60s. And what they did is that they designed a very ingenious technique to study infant perception. And the reason why this was groundbreaking at the time, of course, is because up until that point, we had no way of knowing or understanding the perceptions of infants, because of course you can't ask them. They still have, they're yet to represent the world through symbolic language. So you have to devise a particular research methodology to get at that particular question, and Fance is associated with designing that very research technique or methodology to be able to study children's perception. And the idea behind the task that Fance created comes from the idea of human habituation. And habituation says that if you give children two objects and you watch which they look at for longer, that gives you an indication of which of these objects holds the most interest to them, or at least which of these objects is being processed by their information processing system for a longer period. I'll give you an example, or at least an image of what that looks like. Okay, so here you have on the left-hand side is a replica of this apparatus used by Fance and others in their studies of infant perception. And here are some important results of this research on infant perception. And what the research is really telling us is that even really early on in life, children are more interested, in terms of their perception, in things that resemble human faces. Okay? So anything that looks similar to a human face is gazed at for a longer period of time amongst infants, even as young as 2 and 3 months old. And the research also tells us a number of other things, including that children, for example, like patterns. So they spend more time gazing at patterned, or at least more complex patterns than less complex ones. We also understand from that research that children prefer rounder objects more so than edgier objects, etc. So I guess that's exactly what I just said. So curved patterns are often preferred over straight ones. And as I said earlier, more complex patterns preferred, and normal faces over random patterns are always preferred. And again, this tells you a bit more information about what people were almost evolved to do in their world, what they were particularly designed to do from a very, very young age, as mentioned, as young as 2 or 3 months old, is to process social information, to process faces, for example. So much so that by the age of 7 months, infants are actually quite good at recognizing happy faces, and they can, or at least show an ability to discriminate between these different happy faces. There's another set of extremely interesting studies, and those relate to the visual cliff experiment. So the visual cliff experiment is yet another ingenious way by which psychologists devised the research design to get at infant perception and, in specific, infant depth perception. And obviously, we can't ask infants what they're experiencing in terms of their perceptual experiences. So what we do is we have to design really innovative and, like I was saying earlier, really creative ideas as to how we're going to measure these important life milestones. So what the visual cliff experiments do is that they place a child on a glass plate, and underneath the glass plate, half of the distance is covered with a checkerboard table, if you will. So there's clearly some protection here underneath the glass plate. However, the other half of the glass plate is clearly suspended. There's clearly a drop there. However, the child is, of course, safe because they're suspended through the glass. So the idea here is we're trying to see if children will go beyond that halfway point. So what do we find? We find that at around anywhere from 6 to 14 months, children are old enough to crawl, and therefore they were used, children of that age range, they were used as participants for the visual cliff experiment. And as I was saying earlier, the idea here is to see how many of them and at what age exactly do they travel all the way across, and what age did they stop doing that. And the results are actually quite striking. And what the researchers found at the time was that right around 9 months of age, okay, this is when children start developing this concept of depth perception, understanding that it looks to their field of vision that there's nothing holding them in, or nothing that's protecting them from a fall, and therefore at 9 months of age they stop traveling all the way to the other side of the glass. Okay, so this really demonstrates that around the age of 9 months, this is exactly when we start seeing depth perception start to develop as a developmental milestone. So we're going to jump ship a little bit. We're going to talk about a different topic. So we talked about motor development. We talked about prenatal development and all these important prenatal milestones. And now what we'll be discussing is theories related to cognitive development. So how exactly do we learn? How do we think? How do we communicate? And at what age do we start seeing these important milestones and important changes in the way we perceive the world around us? And all theories, all cognitive theories of development, they differ from one another on 2 important domains. The first of which is this idea of a stage-like versus gradual changes. Okay, that is, do children move in their cognitive development from milestone to milestone to milestone? And do they need to achieve milestone A in order for them to get to milestone B? So that would be stage-like theories, so that they're developing in stages. Or are there no real milestones that need to be reached here, and it's all just a very gradual continuous change that happens over time, and these are gradual type theories of cognitive development. Okay. And there is theories of cognitive development also differ on another respect, which is domain general versus domain specific types of learning or development. Domain general theories say that if you acquire a skill in a particular domain, it'll spill over. That learning will spill over into other domains of life. Whereas domain-specific theories of cognitive development tell you that you have to learn this specific skill, and that specific skill doesn't necessarily generalize to other domains. It's cognitive development is just a collection of you learning very specific skills related to very specific domains. Okay, so these are kind of two important differentiations of theories of cognitive development. And perhaps one of the most influential figures in cognitive development is this man right here, pictured on your right-hand side, is Piaget. Piaget is a Swiss psychologist that, and I think the story here that I keep coming back to again and again and again, is that obviously given the inability of children to discuss the world in which they live, given the obviously their immaturity in terms of their cognitive and linguistic development, psychologists have to come up with really ingenious and really creative and really innovative ways in which to understand the development of children. And cognitive development is no different. Piaget's experiments were really quite ingenious, really quite different given the time in which they arose. And one of the most important contributions that Piaget had over the field of developmental psychology and specific cognitive development of children is this concept that, and remember, up until the point of Piaget and his ingenious ideas, children were really believed to be miniature adults. That is, the quality of thinking possessed by children was believed to be different than that of adults, but only in a matter of degree. Okay, so children just simply don't have enough of the things that adults do. When in fact, what Piaget and his experiments showed is that it's not so much that children are miniature adults lacking or at least showing deficits in adult type thinking, that the quality of their cognition, the quality of their thinking is entirely different from adults. Okay, so it's basically apples and oranges, very, very different modes of thinking. One of the most important concepts in Piaget's work, and this concept actually rears its head time and time again in psychology, and it became a highly influential concept in the field of cognitive psychology, is this concept of schema or schemata, as Piaget called it. And schemas are a way in which we organize the way around us. Okay, so it's a cognitive mechanism through which we classify the world in which we live, in which we organize our experiences, in which we organize our environment. And I will give you an example of what that might look like. So, for example, you might have a schema or an organizing set of neuronal. It's basically a memory representation. Okay, so schema is a memory representation that has within it, that is furnished with details related to a specific concept. And to make it real here, let me give you a concrete example. This concept of a sports car. Okay, so you may have a sports car schema in your head. And the sports car schema has details about what you think a sports car may look like. For example, you may believe that a sports car needs to be fast, it needs to be shiny, it needs to be red, it needs to be expensive, whatever it may be. So that's the way you organize your thinking around that concept of a sports car. And according to Piaget and other cognitive theorists, schemas develop based on one's prior experiences with the world. Okay, so if all the sports cars that you've seen were shiny, fast, they're small, expensive, that is really what you're going to have in terms of the details in your schema about sports cars. And another central concept, again related to this concept of schema or schemata, is a central concept in Piaget's idea is this concept of what he called equilibrium or equilibration. Okay? And equilibration is a process of assimilation and accommodation to existing schemas, and I'll explain what that means in a second. Assimilation is when a new idea or a new experience of some kind is incorporated into an already pre-existing schema about the world. Let's go back to our example of a sports car. Okay? If you have a schema of a sports car and it includes these facts within it, it's fast, it's shiny, it's small, it's expensive, and then you come across another sports car that in fact is red, you may incorporate this new concept of red into your pre-existing schema of a sports car, and that is what Piaget would call assimilation. Okay, so when a new bit of information is added to an already existing structure or schema. And then there's another part of equilibration. And this part is called accommodation. Okay? So it's not only the case that we just kind of slot in new information to pre-existing schemas. Another process could happen by which you actually start changing the schema itself to accommodate a brand new experience. Let's say, again, let's make it concrete. Let's go back to this idea of sports car, this concept, this schema of a sports car. And you may think it's fast, you may think it's shiny, you may think it's small, you may think it's expensive. And then you meet a sports car that defies one of this pre-existing notions about what a sports car is to you. Let's say you see a sports car that's actually quite inexpensive. Okay? So now something must happen to that pre-existing schema in order to incorporate the new information in. And that is exactly what accommodation is. It's when a pre-existing schema is changed in some way, is adapted in some way to fit with a brand new experience that simply just doesn't fit with what you already have. Piaget talked about several, and in fact specifically 4 stages of cognitive development. So Piaget's ideas are actually, his theories of cognitive, or his theory of cognitive development is a stage-like theory of cognitive development to make it more real. And the first stage is the sensorimotor stage. And the sensorimotor stage happens right around the time of birth up until about 2 years of age. And that's when the child is really beginning to interact with their present environment. So, as mentioned earlier, this stage typically extends from the time of birth to about 2 years of age. And this is the time when children are really quite dependent and they're really quite reflexive to the environment in which they find themselves in. Okay? And at around 3 months of age, infants start developing memory for past events, which becomes important in this particular stage of development. With that all said, the sensorimotor stage in Piaget's theory of cognitive development, is typified by two important deficits, and both are related to the deficit of mental representation. Okay? So infants around that time, around anywhere from zero, like just newborn babies, to about 2 years old, they lack the ability to mentally represent their world in this sensorimotor stage, the first stage of cognitive development. And lack of mental representation during this time is typified by they haven't reached two important milestones yet. First of which is called this concept of object permanence. And anybody who's interacted with a very young child probably knows a child, you can have a lot of fun with a child playing just a quick game of peekaboo. And the child is amazed every time you come back into view, because they don't really believe objects continue to exist after they stop seeing it. And that is exactly represented in a deficit related to mental representation. And there's another concept which is called deferred imitation, which is again another evidence of lack of mental representation at that stage of cognitive development, which is this ability to imitate and perform people's actions at a later time. Okay, so it's when a child sees someone perform something and then they imitate them in some way. And obviously this is a very important milestone for both cognition and also social development. Okay, so in terms of object permanence, whether or not something exists even though it's out of sight, right around 11 months, 12 months, this is exactly when you see a spike in when children start gaining that particular milestone, start understanding that even though something stops being in my view, in my field of vision, it may actually still exist somewhere else. Okay, so that's the sensorimotor stage of cognitive development, which is stage number 1. Then there's stage number 2. And stage number 2 is called the preoperational stage. And in Piaget's theory, this stage is pretty much during the period of about 2 to about 6 or 7 years of age. And this is really when the child begins to represent the world in a symbolic fashion. And what does that mean? It's basically the acquisition of language. So the preoperational stage, stage 2, as I was saying earlier, lasts from anywhere from 2 to 6 or 7. And at this stage, the child starts to represent the reality through symbolic thought. Okay, but again, much like the sensorimotor stage, children at this particular juncture still have important deficits that differentiate them from full-grown adults, if you will. One of these deficits is this concept of egocentrism, and egocentrism is the inability to perceive any situation outside of the self. Okay, so children around that age have a very hard time, and in fact, it's impossible for them to think about any situation outside of their own perspective. Another important milestones or important evidence that the child is in this second stage of cognitive development, preoperational stage, is typified by two pieces of evidence, if you will. The concept of centration. And this is the tendency of children at this particular juncture of their cognitive development to become fixated or focused on one small little aspect of a situation or a picture, or whatever it may be, at the expense of the big picture, at the expense of other aspects that may in fact be important. Also, children at the preoperational stage of cognitive development are typified by animistic type thinking, which is the attribution of intentions, of beliefs, of a personality, if you will, to objects, inanimate objects or events. The third stage of cognitive development is called the concrete operational stage. And this is when the child really learns that there are constants in this world. So the third stage of cognitive development, concrete operational stage, lasts anywhere from 6 or 7 to about 11 or 12 years of age. And as I was saying earlier, it's in this period when a child starts noticing there are things in this world that simply don't change, or at least they appear to change, and the appearance could be really deceptive. Okay, and a child in this stage also starts to understand the rules of the environment in which they live. Hallmark feature of the concrete operational stage of cognitive development, in accordance with experiments from Piaget and others, is this concept of conservation. Okay, so this is really when a child gets an understanding that even though an object may be transformed physically, visually in some way, it's still that same object. It's still essentially the same thing. Okay, it's the same number, the same weight, or the same substance or volume. And this was really shown through a series of again, innovative experiments, at least very innovative at the time, because nobody was doing that work, where a child initially sees two glasses that are filled with juice or water at the exact same level. So they have the exact same volume of liquid. And then the researcher takes one of these the contents of one of the glasses into a taller, more narrower glass. Okay, so the shape or the visually, the water or the liquid contained in that glass is transformed in some way. And then the child at the last stage is asked which of these has more in it. Now, if a child is not in this stage of development, so if the child is not in the concrete operational stage of development, so in the preoperational stage, for example, if they have not reached this milestone of conservation, they will point to the taller, narrower glass as containing more liquid in it. And of course, children, when they reach the conservation stage, typically around anywhere from 7 to 12 in this concrete operational stage of cognitive development, they'll tell you they're both the exact same. Okay, because they start understanding that even though something is changed, it may in fact contain the exact same volume or amount or essence of what it is. Okay. The final stage of cognitive development, in accordance with Piaget's cognitive theory of development, is this formal operational stage. And what's different about this one, and this is really anywhere from 12 onwards, what's different about this one is that during this time, this is exactly when the child starts thinking in abstract or symbolic terms, starts thinking of future possibilities, if you will. So as I mentioned, the formal operational stage, which is the final stage of Piaget's cognitive theory, begins at about the age of 12, like I said, onwards. And this is when children start to think in hypothetical terms. As I was mentioning, they start considering future possibilities. They start using deductive reasoning or deductive logic. An adolescent who is at this formal stage of development, or formal operational stage, can actually engage in abstract thought about the world. Okay? So Piaget's theory was and continues to be one of the most influential theories in psychology. In particular, the amount of influence that it had over even things like clinical psychology, where the concept of schema and schemata still matter quite a bit, in fact. Okay? But with that said, the theory is not without its opponents, and the criticisms against Piaget's theory of cognitive development comes from this idea of stage-like versus continuous or gradual change. People who spend a lot of time with children will tell you that development actually is a lot more gradual, a lot more continuous than Piaget's theory would suggest. Not only that, his theory probably, at least this is what opponents of his theory say, it's probably an underestimate of children's competence. And then finally, all the methodology that was used at the time of Piaget was very much in keeping with Western ideals and Western culture. Even the objects used in these experiments were very familiar to children growing up in Western contexts. Despite of these cons, Piaget's theory of cognitive development has a ton of merits, including the fact that, as I have been mentioning, his theory has been extremely influential over the way we think about cognitive development. And one of the most influential aspects of Piaget's theories, as mentioned in the beginning of this chat, is the fact that he showed that children are not really miniature adults, that they have an extremely different quality to the way that they think about the world. Okay? And then the second pro to the cognitive theory of Piaget, cognitive development theory, is the fact that he envisioned learning as an active component that the child actively engages in, as opposed to the child being this passive sponge, if you will. Okay? So the child actually contributes to their own learning and changes the environment in a bidirectional manner. And then finally, his theory showed us that learning one important skill, learning or reaching an important milestone, actually has a spillover effects in other domains of learning. And take, for example, the concept of conservation. Once a child understands that there are a few constants in the world in which they live, they can apply this principle to solve a number of other issues. Until next time.